Hi, welcome to Qubites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we are going to demystify quantum phenomena. And I'm honored to have a special expert guest today for this, my colleague Kevin McCormick. Hi, Kevin, and welcome to the show. How are you today?
Hey, Renee, I'm doing great. How are things on the continent?
Doing okay. Yeah, it's going. Can you tell us a little bit about yourself and your background as it relates to quantum computing, but also other, of course, topics, right, and fields?
Sure. So, as a career, I'm a data architect. I've been working with data for more than 2 decades now, designing, implementing, running, supporting large scale data systems. But before that, my education was in philosophy, and so that got me kind of used to asking big questions like, "What is the nature of reality?" and things of this nature. And more recently than that, I've started to become fascinated, it's not even recent. For a very long time, I have been fascinated with physics itself as the new metaphysics, and now the opportunity to delve into quantum computing as a way to unite that sort of big question side of my intellectual bent with the technical side of my career bent. That's really been like a dream come true.
Awesome. I love these kind of stories where you also have these kind of, intersectional or cross-sectional knowledge and combine it all together. Because yeah, that's I think this is great because we need more diversification in the field, and that
And
because we
passion,
always
right?
need to have a different lens. I think is always helpful. So this is awesome.
Yeah.
And you already alluded to it, that you have been diving into this field since last year quite a bit, and actually not just quite a bit, really extensively. We have been talking a few times before, right? And so you're also currently working to build up Valorem's US quantum practice. And so tell us a little bit about your journey, first of all, and second, of course, about the quantum practice services.
Sure. So, my journey has been really interesting. So, as I mentioned, I have a lot of passion about this stuff, and I have a lot of uh, lay but decent understanding of some of the phenomena behind this stuff. And so, when I've been talking with business leaders, the thing that I've really noticed that there's a lot of confusion and trepidation about how to adopt. And a lot of that is coming from what I would characterize as misinformation. So my passion is for helping others understand difficult concepts, often through metaphor. And I brought a few of those with me here in my back pocket to share with you and your audience. But in terms of to sort of that's enough for there. But you also asked about the services, right? So from a services perspective, we offer strategic road mapping, where we help our clients understand how quantum is going to impact their specific business and strategize about where are the highest value places to go after it first. We also do POCs, often with emulators, to help clients build capabilities within their own organizations, for example, start getting used to the concepts and the type of mathematics that goes into quantum computing. And then, thirdly, of course, is quantum inspired optimization. Quantum computing has brought to the forefront a new way of thinking about mathematicizing problems or restating problems in a new mathematical framework. And that whole family of solutions we're calling quantum inspired optimizations right now. And really, what I'm encouraging everyone to do is prepare today. Today is the time to get started. Today is the day to get started with quantum computing. If you wait till tomorrow is yesterday, you'll already be behind. So my analogy that I use for this quite often is, Blockbuster late in the game tried to compete with Netflix in the mailing space, right? And they even had the
Right.
brick and mortar advantage, which was an advantage at the time, but they were so late to do it
Yeah.
that it was that the opportunity had already passed, right? And now I think there's now one Blockbuster in Oregon left.
Really? There's one left. I didn't know that.
I think so. I think
Wow,
so.
that must be quite a thing to actually go there. Maybe at some point I can bring my kids actually because they have never seen something like this.
Come on, it's right next door.
Oh, that's funny, but yeah, great analogy. Thank you for sharing that. But hey, let's come
Mm,
to the actual topic of our episode, which is the demystification
sure.
of quantum phenomena. Um, What are some of the common mysteries and confusion you actually came across?
Yeah, thanks, Rene. It's a really great question. It's a big question with a very large problem space that we could explore about how to attack it. But I want to start by stating my goal in being here. So, what I want to do is arm your audience with some basic communications and conveyance tools to help them evangelize quantum computing to a broader and broader audience. It is coming. Okay, Q Day is coming, wherein encryption, a lot of our encryption paradigms will be broken. So we need to get on board right now, and we need that interest and that enthusiasm and that commitment to progress to pervade the business layer more deeply. And so that's what I want to try to do, is to arm your audience with some basic evangelization tools. So if I had to think about the sort of center of mass around which a lot of the confusion seems to kind of orbit, I'd have to say that it has to do with the whole perception versus reality dichotomy, right? In our everyday world, where you and I are sitting here at our PCs with tables and desks and whatnot, these objects, the distinction between perception and reality of these objects, of this table, of this laptop, is negligible, right? But at a quantum level, the difference between perception and reality is not negligible. And it's very difficult to convey. Like we start asking really difficult questions, like, are particles really weird in themselves? Or are we just not capable of seeing them not weirdly? Does our perception, does observation bring the weirdness with it? My pushback to that sort of depth of question, that messiness of that question, is, does a business focused stakeholder really need to understand that distinction? And the answer is no. Okay,
Yeah.
the business leader needs a basic understanding, not a comprehensive theory. And a lot of times that basic understanding is going to be targeted and specific to something that they've come across that involves misinformation that they need sort of unwound and rewound so that they can come back at it again from a stable mental framework, so that they can have enough of confidence of understanding that they can know that they can move forward. So when I try to think of making quantum phenomena understandable, what I'm going to do is I'm going to start here by giving you a stack of three. Okay, I'm going to give you a stack of three examples of how to talk to people who are maybe at the very, very beginning, who don't understand what that gentle measurement is impossible at the quantum level, all the way up to the very complex, where we think of a stakeholder who's trying to think of how to use that for their business. So on the one hand, we can use quantum billiards. So imagine a black billiards table, no pockets, no friction, no light. Okay, so we're thinking of billiards at the quantum, in a quantum way, by darkening it, by making it frictionless, right?
Right.
And imagine that I've taken a black ball and I've thrown it on that table. How can I know where the black ball is? I
Hmm.
can't really, right?
Yeah.
Unless I take this other cue ball out of my pocket that just so happens to be glow in the dark, and I throw it onto the table. And eventually those two balls will collide, at which point I will know where the black ball was. And like even a layperson knows that when those two balls collide, the position and trajectory of the black ball will change, right? And so this is an easy way to help people understand that gentle measurement is not possible down at the quantum level.
Right.
In terms of the power of superposition for parallelization, my favorite metaphors to date has been Indiana Jones and I think it was the Holy Grail, where he's going through the cave and passing all of the tests, remember? And he comes
Yep.
to that enormous ravine that's like certain death, but somehow he has to cross it, right? And what does he do? He scoops up a bunch of sand and throws it in a huge arc across his entire, like essentially 180 degrees, right? And some of those grains land on what was originally an invisible bridge, but was actually there the whole time, right? So the metaphor I use for this is that, imagine that instead of throwing a handful of sand, I throw 5 grains of sand that each split many times to form that handful, and that suggests a little bit or helps people get a little bit behind the idea of superpositional parallelization as an empowering instrument and how it can work. Um, but the really the important one is, let's think about how to speak to business leaders about quantum phenomena. And for me, what I want us to start trying to think of is quantum math as a specialized form of statistics, right? With an orchestrated population. We orchestrate the population and then we measure a statistic about it. Statistics has already been very well introduced to the vast majority of organizations, thanks so much to data scientists out there. Um, so the principle that we can convey, that we can carry from the one to the other, is that it is possible to quantify a characteristic of an aggregate, even if you don't characterize each specific individual within that population. So thinking about quantum math as a specialized statistic to measure a specific characteristic about an orchestrated population conveys very easily from data science into quantum computing.
Oh, this is
There's your
awesome.
three.
Yeah, no, love it. Yeah, nice, nice. We got all three of them, and beautiful pictures there with great metaphors. Love it. And great movie. I mean, Indiana Jones, right? These were, and yeah, I
Just
remember like
like
when you were telling this kind of picture, I was totally seeing the movie in front and the bridge, the invisible bridge. But yeah, it's also a great way how you described how measuring works, right? You need to take some action. You need to put some energy into the system, and basically this will change the system, right? So when you measure, there will
yeah,
be some changes involved, and we have to adapt for it, right?
exactly right.
So very important thing.
Exactly right.
But you also mentioned superposition, amazing. But one specific quantum phenomena, which is surrounded by a lot of mystery, we have not touched upon yet, but we need to. It's
Mm,
quantum entanglement, right? Which basically
mm,
describes that qubits can be connected with each other somehow, right? And that property changes applied to one qubit will also affect the entangled qubit, although they might both be physically separated. And Einstein always called this, actually, Einstein actually always questions quantum mechanics until his death, even because a lot of that was just theory until he died, right? But after he died, a lot of that was shown in experiments and so on. But Einstein always questioned, especially entanglement, and called it a spooky action at a distance. And I know you don't like this, but why is that? And what is your take on quantum entanglement?
yeah. So, sorry. Was okay. So, no, I actually agree with Einstein there, right? So, but I agree with him in the way that I'm reading him, which is to say that I agree that kind of mysticism doesn't belong in science. That spookiness. We need to be able to speak about the quantum phenomena, in particular entanglement, coherently, right? In a way that can be understood for the people who need to make practical decisions on the basis of it. So I agree with Einstein's disparagement that we shouldn't there shouldn't be any spookiness involved. We mustn't break the universal speed limit established by general relativity. So entanglement for me is probably one of the most misunderstood quantum phenomena, or well, physical phenomena is probably one of the most misunderstood physical phenomena, okay, of that out there, that we know of yet, right? So the most common misstatement that I've heard about it is something to the effect of, when two particles are entangled and then separated, whatever happens to one automatically happens to the other. And this is just super duper wrong. Okay, that's not what happens. What quantum entanglement truly is at a fundamental level is an inability to quantify or explain or state anything about a single particle separate from the aggregate system. Okay, so what quantum entanglement actually is at a fundamental level is an entanglement of understanding, the inability to articulate one separately from the pair. So I no longer have a left shoe and a right shoe. I just have a pair of shoes,
Right.
essentially. Okay. Um, and this is exactly a question of perception. So thinking back about that perception versus reality idea, there is an element of reality that is weird in there, okay? But it doesn't need to be understood ontologically, like at the fundamental reality basis, in order for a business person to be able to wrap their head around it, right? So let's think about making it understandable. So instead of thinking about it as some sort of mystical or mythical relationship between two particles that are somehow communicating instantaneously faster than the speed of light, let's think about it instead as a, a relationship of complementarity between two particles. So the two metaphors that I've used, these are more recent because I've had to really grapple with this more recently. But I have a little dog here named Achilles. He's a little black dog. I love him to death. He also has a best buddy right across the courtyard there, who is another black dog. And in the evening, when they're running around the courtyard, tumbling and wrestling, which they love, it is impossible to distinguish where one of them ends and the other one, where one of them begins and the other one ends. Like it's just a giant rumbling ball of black fur as they tumble and wrestle with each other. So if I were to look away from them and they were to run apart, and I go and look at one of them and I see, oh, that's Hennessy. Okay, well, I know Achilles must be behind the other place, right? They ran separately. Um, that's what entanglement fundamentally is a relationship of complementarity where these two were entangled together and I didn't know which was which. I just knew that they were both there. Then they separated, and then having observed one, I know what the other one would have been if I had checked it, okay, or will be when I check it.
Gotcha.
So Dr. Susskind, the Stanford professor, gave an even simpler example. He said, imagine I have a nickel and a dime in my pocket, and without looking at them, I give them to two people. Then I call one of them and I say, hey, which coin did I give you? And he says, the nickel. Well, then I know that I gave her the dime because that's all that's left. So again, it's that relationship of complementarity
Yeah.
between the two that's most essential to the entanglement phenomenon.
Love it. That's a beautiful explanation, and also, of course, love this story with your dog and the body that is just
It makes a lot of sense.
a furry ball in the evening, kind of, and it's so nice because exactly that's the problem, right? You don't even know if maybe there's a cat in between them, right? You still don't see it. It's like you know, but yeah, it's a great explanation. Well, we could talk for much more, but we're already at the end of the
We
show.
could.
Thank you so much, Kevin, for joining us today and sharing your insights. This is very much appreciated. But before we leave, do you have any parting thoughts for our audience today?
Um, sure. So, we've done a lot of kind of surface level thinking about this sort of stuff, right? We're trying to introduce novices to deep concepts without breaking their brains, right? So, I want to leave your audience with one more question that definitely stems from my sort of philosophic education, which is this. I'll give you one observation. There are two things in the universe that respond differently, that behave differently, depending on whether or not they're observed. And those two things are quantum particles and consciousnesses.
Mhm.
This is either the most staggering coincidence in the universe by far, or the evidence of some interesting relationship between these two things. Enjoy that thought.
Awesome, love it. Well, folks, there's something to think about it, and in the break here until you can watch the next episode. But hey, thank you so much again, Kevin, and thanks everyone for joining us for yet another episode of Qubites, your bite-sized piece of quantum computing. You know the drill. Watch our blog, follow our social media channels to hear all about the next episodes, and of course, on our website you can find all the previous episodes, season 1 to 5 now already. And again, thank you so much, Kevin, and take care and see you soon. Bye bye.
Thank you so much. Bye bye.